Hello students, welcome back to the world of RoboMate. Students, very nice to see you students. So, we have been discussing the chapter, yes, circular motion. Now we are going to start with the next entrance module of the chapter circular motion. What we are going to do in this module? Yes students, in this module, we are going to discuss multiple choice questions based on the concept of angular velocity. So students, I am very sure you have studied this concept of angular velocity. Have you revised all the formulas? Oh, you have revised? Fine, then without wasting any time, let me start the module. Let us take a look at the first question. There you go. Okay, it's a simple question. An automobile takes a U-turn in 4 seconds. Then its average angular velocity is, okay, what are the options? Option A, pi by 2 radian per second. Option B, pi by 3 radian per second. Option C, pi by 4 radian per second. Option D, pi by 5 radian per second. Okay, students, what is the procedure to solve this question? Yes, identify, set up, execute and evaluate. I see. Alright, now this is a very simple problem. Alright, you should be able to do it. Fine, anyway, let us move on to the solution. First part is identifying and setting up the problem. Alright, now, what is given? Yes, I'm asking you, what is given? Yes, an automobile takes a U-turn in 4 seconds. Okay, alright. Now, let this point be an automobile. Don't laugh. Don't laugh. In physics, we can consider this. Yes or no? This automobile can be considered as a point object. So this point object is your automobile. Alright, it is at point A. Now it is going to take a U-turn. U-turn means what? U-turn. See there. This is your U-turn. U-turn means what? It is a semicircle. So now the automobile has taken a U-turn. Now it has reached another point B. Is that clear? Now, O is the center of that semicircle. OA is the initial radius vector. OB is the final radius vector. Now the radius vector has swept through an angle theta. Now, what is the value of this theta? What? Yes, semicircle. What is the value of the theta? Yes, very good. Theta is 180 degree. That is pi radian. So theta is pi radian. Fine. You see with the diagram how much we have understood. Now, let's move on to the question. What else is given? Yes, see that. An automobile takes a U-turn in 4 seconds. So time is given as 4 seconds. Fine. So we have identified and we have set up. What is asked? Yes, they are asking what is the average angular velocity. That is omega is asked. Now, which formula? Yes, which formula? Very good. Omega is theta upon t. So here theta is there. Yes or no? Theta is pi radian. T is 4 seconds. What do you get omega as? Omega as pi by 4. Pi by 4 radian per second. So which is the correct option, students? Yes, option C is the correct one. Such a simple problem. But if you don't draw the diagram, then it's gone. Is that clear? It's all very simple, students. You are all capable of doing such problems. Is that clear? Let's move on to the next question. Oh, single line. The angular speed of a flywheel making 120 RPM is options. Option A, 2 pi radian per second. Option B, 4 pi square radian per second. Option C, 4 pi radian per second. Option D, pi radian per second. Fine, students. Procedure. Yes, identify, set up, execute and evaluate. Right. First, let us identify and set it up. What's given, students? Yes, the angular speed of a flywheel making 120 RPM. So frequency is given, 120 RPM. 120 RPM. RPS you have to convert. What you should do? Yes, you have to divide it by 60. So 120 upon 60 is? 120 upon 60 is 2 RPS. So N is equal to 2 RPS. Fine. Anything else is given? No. What is asked? They are asking angular speed. Angular speed means omega. Which formula? What? No, don't give wrong formulas. Come on. N is there. How will you find out omega? Yes, you said something. What is that? Very good. Omega is 2 pi n. Now we have n as 2 RPS. So what will be omega? Omega will be 2 pi into 2, which is nothing but 4 pi. So omega is 4 pi radian per second. Which option, students? Yes, again option C. Is that clear? So students, these are all very simple problems. Alright, if you identify and set it up, easily you can solve this problem. Is that clear? So students, time for me to leave. I'll catch you up in the next module. Until then, students, keep working. You're all born to win. Rise and shine.